Algebra 1, Module 1, Quantitative Reasoning, Lesson 1.2, Modeling Quantities. This is a summary of the lesson that was in the class, so it won't be as detailed, but it will give you a good overview as a review or in case you're absent. Okay, here's a warm-up. Do your best. Pause the video first, please. Okay, the answers are here. In this particular case, we are given that profit P is equal to 8n plus minus 30, right? And it says that item N, number of item N are sold for $8 each, and expenses totaling $30 are subtracted. If the profit is $170, how many items did you buy? Well, this 170 represents profit, which is a P. So what we do is we plug 170 into P, and we end up with this particular formula. And in solving for that, we add 30 to both sides. Writing this is not necessary. So you could go directly maybe to this point, and then you could divide by 8, and then that will yield you 25. That means that 25 items were bought. In the same number of items were bought, but the expense changed to $40. So instead of 30, it is 40 right here, right? Would the profit increase or decrease? And but if so, by how much? Well, we're assuming everything else remains the same, right? And then, which means that this N right here represents now $25 that we found earlier. When you plug it in, as it turns out, my profit is $160. Well, that makes sense because if your cost of doing a business goes up, obviously your profit goes down because this 8N is the revenue, right? Because revenue hasn't changed. So therefore, the profit would decrease by $10 to 160. Since the amount of the expenses increased, this takes the money away from the profit. Makes perfect sense, right? Nice. Okay, guys. Now we have this question, and we will be learning today about ratios and proportions are very useful when solving a real life problem. Ratio is a comparison of two numbers by division, and we've seen a couple of examples of that in an earlier lesson. And the equation states that two ratios are equal, and that is called proportions. Okay, so we'll be utilizing that to solve this. Now, according to this, totem pole is 90 feet tall, casts a shadow of 45 feet. So pole is right here, shadows over here, and we're assuming that sun is like here or something like that, right? Casting a shadow like this. Well, because sun is so far away, the angle at which it casts shadow will remain the same, whether you're talking about a gigantic 90 feet tall totem pole or merely 6 feet tall gentleman, like so. So what do you think that means, guys? Right. It creates the same shape over here, this triangle. Therefore, the ratio of the two must be the same, right? Given that information, why don't you go ahead and try to solve this, okay? Answer all these questions, guys. Okay, I'm back. I'm going to assume that you worked on it for a little bit, or at least thought about it, and work with me on this one, guys, okay? Now, there are a couple of ways to do this, actually. You could set up the fraction according to the height. So in this height, the ratio of the height might be, let's say, height of the man divided by the height of the pole. We always go in the same direction, guys, okay? Which gives you 6/9. How about the shadow? So shadow of the man we don't know is x divided by 45. That's what you get. And these two ratios, therefore, must be the same. If we set it equal to each other, cross multiply, but notice, I do not multiply 6 times 45. Just give me a second, okay? Now, once you do that, we got 90x on the left-hand side. How do I isolate the x? If you said divide by 90, you're absolutely correct. Now, once you do that, we have 6 times 45 divided by 90. But what do you notice? This right here is clearly 1/2. So 6 times 1/2 is 3. So this is a lot easier than, let's say, if you multiply these two values, which will yield a big number, right? 270, I believe, right? And then you have to divide by 90. It's better to leave it factored and using smaller numbers, create a fraction, and it makes a much small size calculations, and you don't need to use your calculator, and it works your brain muscles, right? The alternate approach is that maybe I want to find a ratio based on numbers from just pole. For example, shadow divided by height. If you do that to the man, shadow is the x, the height is 6. So this particular ratio, as long as it's made consistently, the ratio should be the same. And when I set these two equal to each other, I end up with this. When I cross multiply, look, I end up with the same thing. Therefore, the rest of the work is exactly the same. So the shadow length is 3. Oh, sorry, shadow length of the 6 feet tall gentleman. All right, guys, that was period 4 work. It's very similar. All right, let's go to the next page of notes. In here, we talk about scale drawing. Okay. Once again, the scale is a type of ratio of any length in a scale drawing or scale model to the corresponding actual length. A drawing that uses scale to represent an object as smaller or larger than original object is called scale drawing. Most of the time, such as a map, scale drawing would be smaller than actual, because I think, let's say distance between San Francisco and San Jose, I don't know, it's about 60, 40, 50, 60 miles, right? If you have it bigger, you're going to have the map that's actually bigger than the actual distance, and that's not very useful, is it? All right. So most of the time, especially things like a map, scale drawings are actually smaller. But there are times when we need to make things bigger. So let's say if you have an atom, which is really not visible by human eyes, you want to make it bigger so that it is visible. So they could be handled by hand, so we get a better understanding. And it'll be a good learning tool, right? All right. Now, there's also a three-dimensional models that uses a scale to represent objects either smaller or larger than actual object is called scale model. So if it's a 3D object, it's a scale model. If it's a 2D drawing, it is a scale drawing. Why don't you go ahead and do me a huge favor. Try example 1, A and B. Pause the video, please. And please, on B, follow the direction and round your answer to the nearest tenth. And whenever we have a direction like that, it means that you should probably use a calculator. So if you don't have it with you, please get it ready. Pause the video. Okay, here we go. Let me zoom into 1A. Okay. The actual distance from Chicago to Evanston is 11.25 miles, right? So what is the distance on the map? The important information was here. 1 inch corresponds to 18 miles. So what I did immediately is to say map distance divided by the actual, 1 inch divided by 18 miles. And then for the actual distance right here, what's the distance on a map, D, when the distance between the two cities is 11.25. Now here you could cross multiply if you like. Alternate way of thinking about that is, how do I get rid of 11.25 on the right hand side? We multiply by it. Right, that will cross cancel. And the left hand side is 11.25 divided by 18. Alternatively, the way that it appears here is that I cross multiplied it this way. But I only cross multiply the bottom part, because by doing so, you're left with the D. Well, either way, you're left with this times this value right there, 11.25. Put that on the calculator, you get 0.625 inches. Because it didn't ask you to the round, it came exactly to 0.625. We leave it as it is. Okay? So the distance between Chicago and Evanston on a map drawing is 0.625 inches. All right, now let's compare the question B. It says the actual distance between the Chicago and the city of, sorry, I don't know how to pronounce it, Waukegan, is 4 miles. So we have the same exact setup. I just copy this from the other side. And then distance between two cities on a drawing is a D. The actual is 4 miles. Remember, this entire ratio premise was map distance divided by the actual distance. You have to be very consistent. Similar to the problem A, to get rid of the 4, to divide by 4, you multiply by 4 to get rid of it. Once you do that, we end up with this. I rewrote it down here. And then 4 over 8 is 1/2, times 1 is half. So the distance on a map is 1/2 an inch. Okay, so we have a dimensional analysis, right? Let's work on that problem, shall we? You know what? I will work this out from scratch. So let me go to the previous page right here, and I'm gonna put it right here, guys. Dimensional analysis, aka also known as a unit conversion. When I was a student, a young person, we just called it unit conversion. Now we have a fancy name called dimensional analysis. And once you take a chemistry and other science classes, you'll be using this quite often. Okay, is a method of manipulating a unit measure algebraically to determine the proper unit for the quantity computed algebraically. The comparison of the two quantities with different units is called rate. The ratio of the two equal quantities, each measured in different unit, is called conversion factor. Okay, so how do I do this? So we use dimensional analysis to convert measurement unit. So for example, apparently a large adult male has about 12 pints of blood. We're going to use dimensional analysis to convert this quantity in terms of gallon. How do I do that? Okay, we start with the known value, which is 12 pints. But we ultimately want to get to gallons. But I don't have a relationship between pint and a gallon, but I do have a relationship to pint and a quart. And then once you have the quart, now there's a relationship between quart and a gallon. So it'll be a two-step process. Now, we know that these two values are exactly the same. So what that means is that I can multiply by it, a fraction. If you have a value up top divided by the same equivalent value, when you divide by something of equal value, that's equal to 1. What happens when you multiply by 1? Nothing. That's the beauty of multiplying by 1. Right. But we don't want pint. So how do we cancel that? How do we get rid of it? Well, by putting pint on the denominator. And there's a relationship between a pint and a quart. So the quart goes in the numerator because that's a value that we want, at least temporarily. So what is the relationship between a quart and a pint? Is, according to this, 1 quart is equal to 2 pints. There you go. Now, as you could clearly see in this case, the pints cancel. So when you work out the number, 1/2 times 12, that is now equal to 6 quarts, right? But according to this, 4 quart is equal to 1 gallon. Okay, I don't want a gallon. Sorry, I want the gallon. I just don't want the quart. I want to get rid of the quart. So what you would do is put the quart in the denominator, because why denominator? Because quart is in the numerator here, and I don't want it. I want to get rid of it. So you put it in the other side. And whatever you want is always in the numerator, gallon. So according to this relationship right here, 1 gallon is equal to 4 quart. If you do that, the quarts cancel. So you're left with a gallon. So when you put it all together, that is equal to basically 12 times 1/2 times 1/4 of a gallon. You can see that when you multiply these two, that's 6, right? So 6 times 1/4, I believe that's 3/2, right? 3/2 gallon. Or if you prefer, you could just say 2 goes into 2, and 2 goes in there 6 times. So 6/4, and you could take one more step to do that. And if you want, you could even convert that to decimal if you like. Not necessary, but you can. So what that ultimately means is that 12 pint is equal to 1.5 gallons. So that is how much blood is in adult male's body on average. A large adult male human. I don't know if that's actually true, but the textbooks generally, they try to use the real number, so I'm going to assume that it is true. All right, let's look at B. Okay. You know what? For this one, I'm going to just show you what I did in the class. That way, we'll go a little bit quicker, so the video is not too long. All right, the B is this. We wanted 720 inches. We want to convert to yards, but I don't have a direct comparison from inches to yard. But I do know that 12 inches is equal to 1 foot. So we're going to use that as an intermediary conversion factor. So 720 inches, we want to get rid of the inches. That's in the numerator, right? So we put the 12 inches in the denominator. Its equivalent value, put in the numerator, 1 foot. So the inches cancel. Now we're left with a foot. Now we do know that 3 feet is equal to 1 yard. So if you want to get rid of the feet, you put that in the denominator. 3 feet is in the denominator. Its equivalent value is in the numerator. Once again, because these two are equivalent values, when you divide by them, that is equal to 1, and that is also equal to 1. Therefore, the value actually does not change. It just changes to a different unit value of the equivalent value. Okay? Well, anyways, by doing so, the inches cancel this way as a summary, and the feet cancel, and you're left with a yard. Now what we're going to do is multiply the numbers that we see. We got 720, 1/12 over here, and 1/3 over here. We clean it up, and that yields 20 yards. If you don't see it right away, you could see that that is 36, right? So this intermediate step is 720 divided by 36 yard, and 36 is 1/2 of 72, or that is 2 times a 0 gives you 20 yards, okay? There are many ways to figure this out. Okay, guys. So now we have your turn. Oh, by the way, please don't do this. Yeah, don't worry about that one. Try these 3 questions. Please pause the video. Okay, guys. The answers are right there. The idea is very similar. And for 4 and 6, okay, forget about this. This goes here. And for number 6, it's here. But once again, I went through 4 and 6 a little bit more in detail in class. Okay. So seeing that this is a recap, I'll just move on. If you need to take a look at this for a little bit longer, please just pause the video. Okay, so example number 3. Using dimensional analysis to convert and compare rates. So in this case, for charity event, Amanda traveled 105 kilometers in 4.2 hours. And the Brenda traveled 0.2 miles per minute. Oh my gosh. One is kilometers per hour. The other one is miles per minute. We don't really use either one, but internationally, kilometers per hour is actually the one that we use. And if you look at the B, it is stack of book is 4.10 kilogram for every meter of height. That's a metric number. And this is at 3 pounds for every foot. So why don't you do me a favor? Why don't we convert all the values to metric and then compare the two values, right? All right, guys, pause the video. Okay, how did it go for you guys? I'm going to show you the answers, okay? If this is a class, you would have had a chance to work with your mates. Here you go. So Amanda, the rate for the Amanda, we R sub A, and that was, you know what? I don't know why I did this in period 2. I believe period 4. Yes, I did. We left Amanda alone. It's when you do a long division, just gives you 25 kilometers per hour. Very nice. And let's go Brenda. Brenda is 0.2 miles per minute. We don't like this mile. So put it 1 mile in the denominator to could cross cancel. But what is this equivalent value? 1.61 kilometers. And I put that in the numerator. When you cross cancel, I have a kilometer. But I don't want the minute. I want to have it in terms of an hour, right? To cross cancel, we need to put the minute and hour on the bottom. And the relationship is that for every 1 hour is 60 minutes. So when you do that, all this units cancel. And we are left with kilometers divided by hour, which is what we want. Good. We're happy with that. Now all we got to do is multiply the numbers that are remaining here. Right? That gives you 0.2 times 1.61 times 60. Put that in a calculator, which will yield 19.32 kilometers per hour. When you compare them, Amanda is going 25 kilometers per hour, and Brenda is going 19.32 kilometers per hour. So Amanda is moving faster. Okay. In part B, we're going to leave the books alone, which is a 4.10 kilometers per every meter of the stack. It weighs 4.10 kilograms. 1 kilogram, I believe, is 2.2 pounds. So that's about almost 9 kilogram, I guess. 9 pounds, almost. Yeah. All right. Magazine, though, is 3 pounds for every linear foot, right? So we're going to do a conversion. All right, let's start with the pounds here. Because that's in the numerator, we're going to put 1 pound in the denominator. And what is that equal to? According to this information, it's equal to 0.45 kilograms. So we got the kilogram right there. So we're happy with the kilogram. But we don't want the foot. So we're going to put the foot in the numerator and the meter in the denominator. The relationship between the two is that 1 meter is equal to 3.28 feet. So we put 3.28 feet in the numerator, 1 meter in the denominator. And we know that these two canceled and these two cancel. We're left with kilogram per meter, which is what we have over here. And I'm happy with that. Now we're going to deal with, right there, right? We're going to deal with numbers. 3 times 0.45 times 3.28. I don't worry about these two ones because when you divide by 1, nothing really happens. And that yields 4.4. 4.4. So now the book weighs, its mass is 4.10 kilogram for every linear meter. And for magazines, it's 4.4 kilogram for every linear meter. So what that means is that magazine has a greater mass per unit of height. Okay, guys, we're almost done, right? So we're going to learn. Let me just show you what we just did. Okay. We want to be able to graph this thing. So what we did in class was that Simon sold candles to raise money for the school dance. He raised a total of $25 for 10 candles. Find the rate, amount earned per candle, and then graph the relationship. Find the unit rate. So all we gotta do is amount of money earned, $25, divided by amount sold. So we have dollars per candle. All you gotta do is find out what 25 divided by 10 is. That's $2.50. So all that means is that it will cost for every candle they raised $2.50. So that, because the denominator is 1, we call that the unit rate. What is the ratio rate or the slope for each 1 unit? Okie dokie. How do you graph it? Well, we're going to find 25. So all I did was 1, 2, 3, 4, 5. Each one is 2. So that's 10. That's 20. So this 1, 2.5. 25 goes all the way through. And here, that's 5 and a 10. It goes straight up. It meets at this point. And then if you don't buy any candles, you don't make any money, 0, 0, when you connect it this way. So that will be the graph. So that will be the relationship, guys. So if you buy 10 candles, you just earned yourself $25, right? So in the x-axis is the number of candles, y-axis is the amount of dollars. So this graph represents the relationship between the money earned from the number of candles sold. It's a linear relationship. In the same idea, you get 8 corn muffins. That's it. The number that you sell will affect how much you make. So the independent variable goes in the x-axis, right? And then dependent variable, because the amount of money depends on the amount of muffins sold. In this case, the money that you make depends on the amount of candles sold. So the independent variable is usually, we put it, well, almost always, put it in the x-axis. Okay, similar to the previous problem, we divide the amount of money divided by the amount sold. When you do the math over here, simple arithmetics, we end up with the $0.75 or 75 cents for each muffin. So that's the unit price or the slope of this graph. And I don't know if you noticed this, but I'm doing my best to change the scale. So instead of going 1, 2, 3, 4, 5, 6, which give you really point that's really, really close, like here, like this, right? I'm kind of expanding it out. I'm trying to push out the 6 as high as I can so I could take advantage of all the real estate that I have. Okay? So that's the only thing that I ask you to do is try to fill out the graph as much as you can. Okay? All right, guys. That should be it for us. But for now, we have, as a last exercise, here we go. Oh, please note that 5,280 feet is equal to 1 mile. And please do these, your turn, here. Normally in a classroom, you guys would actually, after you finish working, check the answer with each other. But when you're watching a video or you're absent, just pause it. Go ahead. Okay, guys. All right, here are the answers. If you have further questions from watching this video, you could just come see me during tutorial and I can explain to you in a little more detail. I don't want to be too redundant on a video, so I'll see you again in the next video. Have a good night.